All right, we have all the pieces, well, almost all the pieces to be able to graph a polynomial function. The last thing that we just need to be aware of is an important property talking about the local extrema of a polynomial. So when I say extrema, remember that encompasses local mins and local maxes. But if we look at local maxima and minima, okay, if we have a polynomial of degree n, then most we have of the number of local extrema is n minus 1, okay? Commonly, we think of these as turning points, but just for our awareness, if we have another way that this could be helpful is in doing sort of a reality check of our answer. Do we see more turning points than we have the degree of the function? If we do, something's wrong, okay? If we have fewer turning points or fewer maxima or minima, then we're probably okay. And of course, we always have a graphing utility to check our answer, but who wants to use those? Those are boring. Not really. But here's how we're going to graph a polynomial function. And it's doing everything that we've already done. So we're going to find and plot all the zeros and make note of their order. And then again, keeping in mind how their order affects their representation on a graph. Make a table of values for in between or on either side of the zeros to determine whether it's positive or negative there. That's number 2. Leading term test to determine long-term behavior. And then the last 3 are kind of new, but they're just kind of things to polish the thing off. So y-intercept, and there's actually only one. I don't know why I said S. And then symmetry. Symmetry could be helpful. Determine whether the function is even or odd. And then do that last reality check to make sure that your number of extrema, local extrema that is less than the degree of f of x. So here we go. So just to recap, we've already done all the different pieces, but we need to assemble them. So we have the zeros previously found as 0, 3, and negative 3, and their orders were 3, 2, and 1. Okay? And then what we did with that after then is said, okay, here is our number line, here were our zeros, negative 3, 0, and 3. And then we took test values. We took negative 4, negative 1, positive 1, and positive 4. And we said that it was greater than 0, 0, and then less than 0, 0, greater than 0, 0, greater than 0. Okay, so that was super helpful. In another video, we actually looked at the long-term behavior too. We said that an was greater than 0 and n was even. So that meant the long-term behavior in terms of arrow notation was up and up as we went to the left and to the right. Okay, so that's super helpful. The last thing, so let's see, I'm going to put all this information on a graph. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, and so I know it's zeros there, there, and there. Okay, and so then the initial graph that we had looks something like this. Crosses and flattens, right? Goes up, comes down, touches and turns around, but kind of flattens as best as we can show that, and there we go. I could also compute, f of 0, that's 0, okay, it happens to be a 0. Okay, so that would be the y-intercept. Symmetry, this is not an even function, even or odd. It's neither because the degrees of the different terms are both even and odd. A simple way to check for even functions is you'd have to have all even degrees, and an odd function would have to have all odd degrees of individual terms. So there we go. So, okay, and then let's see. The only thing I haven't done is use this this long-term behavior, so I know that as I go to the right, I need to go up, and it would continue forever and ever. So I do need arrows on both ends, so it's up and up as I go away. Now here, I fully recognize I have not done specific values along the vertical axis. That is okay when you're graphing by hand. We'll save the vertical axis values for either the y-intercept, vertical intercept, or graphing utility. Okay, so there we go. Okay, and last kind of reality check, we want to just confirm that the extrema, the number of those, is less than the degree. So the degree is 8, and I have a total of 1, 2, 3 extreme values that are local mins or maxes. That is less, so this is okay. And if you really want to check, make your own graph. Okay, here is another function. Okay, I want you to pause the video, do everything that we need to, so get the zeros, their orders, function values between them, intercept, long-term behavior, etc., etc. Get all that information and then compare it to the solution you're about to see. Here's my solution. So I began with factoring to find the zeros. So I found a 0 at 0, 0 at 2, order 1 and 2 respectively. So that means that at 1 I cross through and at 2 I touch and turn around. And then I made my number line just to kind of show, okay, here are the zeros, here are some values on either side of the zeros, and I determined whether the function was positive or negative there. Okay. Again, you could do the actual value and calculation. I just kind of did mental math like, oh, okay, is it going to be positive or negative? Okay, there we go. And then after this, I said, okay, let's look at that leading term. It's negative x cubed, where n is 3, an is less than 0. So that means long-term behavior, LTB, has arrow notation up and down. And then I also know that the intercept is at 0, 0. Okay. Oh, here we go. And then, so I kind of put it all in the graph. So I said, okay, at 0, I had to make sure it crossed through. At 2, I need to make sure it touched and turned around. And then I said, okay, it's positive before 0, negative between 0 and 2, and negative thereafter. So there we go. And the last thing I could check is, number of extrema. This is, let's see, according to my function, I'd have 2. Okay, so 2, and that's less than 3, so we are okay. All right, I always want to just do that as a reality check to make sure that we are okay. But there we go. You are ready to graph polynomials on your own, or at least with the help of some others. So we'll get some practice with this in class.